Okay, now that we've done this, and we've got a decent solution, let's go back and look, for example, at our boundary. Here we see our boundary. We see our load of 1,000. But what we want to do is we want to basically put a spring right here at 10. There's not too much ways of doing that unless we're going to zoom in around 10 and see if I've got some particular manner of producing a small bump right here at 10 that'll look like that. Now if I go back to the drawing and then look at the boundary and remove all the subdomains, I've got a little part sticking out of here that if you look, you can't really see, but it does exist. And maybe I made it too small, that's granted, but right here you can't tell. But I really do need to know the dimensions. So what I'm going to do is I'm going to save this one as, and I'm going to have to go back in here, but this time I'm going to beam case spring 01. And let's go back in and see if I can find it. Beam case spring 01. Now what I've got here is the original rectangle. I've got a new one. And it looks fairly small. It looks like it's 9. It starts at 9.99, so it's almost 10. So what I'm going to do is I'm going to start it at 9.9. I'm going to basically, whoops, here. I think, let's see, Control Z. Okay, I had the 9.9, 10.1 minus, I'll go ahead and say 0.1. Now this may be too much, and just anything above 0, so I'll just make that. Now what I'll do is run this case. Uh-oh. Now, what happened here was an issue that occurs occasionally where it picked a reference to the last case. So what I'm going to do is do a copy. I'm going to go back into beam case 2. I'm going to save as. I'm going to go back in and I'm going to save it as 2 right here. Then it is saved as 2. I'm going to put this in here. Get rid of that one. Now you've got a problem here. And the boundary condition specification. So I need to figure out how to get rid of everything and just go back to, okay, mesh generation. I'm going to get rid of the mesh, PDE coefficients. I'm essentially going to get rid of solve perimeter and solve the PDE. I'm going to get rid of all those, run that. Okay, that's not working. So it looks like I may have to go back in. Let's go this way. Take that out. All right. Looks to me like I got to start over. So, not a big deal. I can do it. No, want to do it. Doesn't matter. So let's just start it over. Here. Put in 2 rectangles. Doesn't matter where they are. Just put them in. Then save as. I'm going to save it right here. Okay. Next thing is I'm going to bring up 2 of these, and this is the original back here. It's got all this mess back into here. Grab these 2, do a copy. Let's see if I can put them right there and comment these out and run this case. And I did. Okay, the next thing I need to do, go in and set my limits off of what I had off the original beam case. So let's take beam case 2, take the X and Y limit there, copy. Okay, let's run that one. Alright, it's looking pretty good. What I want to do now, I want to zoom in on the bottom of this and notice something here. How wide it is and how thick it is. Because what I need to do is I need to, on the base or bottom of this, I need to have a spring which pushes up against this. So, with that in mind, I'm going to hit the boundaries. Okay, I'm going to select all the boundaries. Let's see, edit, select them all, double click, whoops, edit, select them all, double click. Have the wrong type of equation, so let's go into plane stress. Now, select them all. Go to no surface tractions. Then I'm going to go over here and I'm going to put a fixed location. And now I'm going to, I might as well hit the top of the beam with a load of minus 1,000. Now I'm going to go down to the very, very bottom here. And I am going to select that bottom. And I'm going to put spring constants here. Now, if you stare real close at this, you will notice that your Q times your U is going to be your load. In other words, I know it's not the most favorable thing, but let's take a look at this. Here. Alright, you're going to have to bear with me for a minute as I get rid of all this mess. Okay, so let's go back to a pin here. Let's see. If I go back and forth between these two, what you'll notice is N times C times the gradient of U, Q times U equal to G. Now I don't have a G here, but I could have a Q in which I'm trying to get a value of a force in here. So a spring constant, essentially. How do you put that so that there's a spring constant on that point? Well, first, let's just put 1,000 and see what happens. Okay. Now, I'll go ahead and take the boundary and remove the subdomain. Hit this with the mesh. And again, I'm just running a trial on it. I'm going to solve it. And there may be an issue here, but let's see. The first issue is it looks like the boundaries got all set. So I need to go back to the boundary term. And what do I have here? Oh, they all got reset. Okay. So here's what I'm going to do. Go back to the boundaries, select all. They're all Newman, except one location right here. It's a deer sleigh or 0. displacement. I'll put a gnome on of minus 1,000. I'll go down here to the very bottom. Maybe I can hit it. And I'll put a spring constant of a large number. And now hit it with a mesh and solve it. Okay. So let's look at this. One way we could look at it is zoom in on that spot. And what you notice is something a little bit interesting. Too large of a load, essentially. So I'm going to run back to here. And don't tell me I just lost my boundary conditions again. No. Maybe I hit the boundary condition in the wrong location. Okay. Where did I hit this boundary at? Oh, I double-clicked the wrong location here. Okay. This was the one. Let's just say 1,000 for the time being. Okay, double-click here. Double-click here. Double-click here. Looks like I accidentally hit the wrong location. That's looking a little bit better. So in this particular instance, if the deflection was down, the force got pushed up. Let's see what would happen if I started playing with this a little bit, and I'll come back in a little bit and get the right value here. Okay, so here, let's take one of the zeros off of it. So you'll see it less and less of an effect. Let's go back to it, and let's even do a minus large number. Just playing around, experimenting. That doesn't look quite right. So what we're going to do is pause for a minute and go to another video, because I need to make this video on another computer and come back here. And let's investigate this boundary condition, and I'll freeze it and we'll return to it.